I'm honored to present the poster communication for the second National Conference on Applied Science and Advanced Materials. This work is presented by SERIDI Fatiha from Laboratory of Physics Material, University May 8, Gelma, Algeria. The communication is entitled Effect of Synthesis Process on Structural and Magnetic Properties of NEPT-based Syria Nanoparticles. Magnetic nanomaterials are among the main classes of nanomaterials having new properties. Various applications for magnetic nanoparticles such as magnetic sensors, magnetic resonance imaging, information storage systems, and magnetic recording media. Nickel is of great industrial importance in nanomagnetism. Cerium oxide is from rare earth oxides. It exhibits unique properties owing to its infill for f orbitals. The efficiency of a material depends strongly on its structure and consequently its synthesis method. The present work aims to study the effects of synthesis method on the magnetic properties of Syria B doped by nickel and platinum. For that, samples are synthesized by hydrogen reduction method or gamma rays irradiation. Morphology, structural properties, and magnetic behavior were studied using different techniques as X-ray-D, SEM, and VSR. Samples were prepared using co-impregnation of the ionic precursor method according to the composition 5-way percent of nickel and different levels of platinum supported on Syria. At first, nickel salt as nickel formate, platinum salt as platinum diamine dichloride, and cerium oxide support were dissolved in calculated volume of distilled water. After adjusting the pH to 11, solution were magnetically stirred for 24 hours and then reduced via two ways, gamma rays reduction and hydrogen flow reduction. Structural and magnetic study of NEPT deposited on Syria reduced under hydrogen flow. The figures present some images of powders in different steps of synthesis. As seen in image A, the support shows a stack of small spherical grains with a smooth and clean surface. Their size is ranging from 2 to 5 micrometers. The micrograph B of bimetallic NEPT deposited on cerium oxide during impregnation shows a similar morphology to that of the oxide. At C, the reduced one shows the appearance of new morphology, small free clusters as well as small particles distributed on the oxide surface. The X-ray-D pattern of 5% nickel, 0.5% platinum deposited on Syria powder showed a cubic crystal structure of support. The most intense diffraction peaks and their corresponding diffracted planes are presented in the table. Crystallite size of Syria calculated using Scherer relation is about 10 nanometer. It is also shown the appearance of two new peaks with low intensity indicating the presence of nickel metallic phase. The magnetic measurements of samples recorded at 300 Kelvin show a ferromagnetic behavior for all the samples. According to previous reports, stoichiometric Syria is diamagnetic. The ferromagnetic behavior is related to the exchange interactions between unpaired spins resulting from surface oxygen vacancies of Syria and dopant ions. So substitution with metal ions should create more oxygen vacancies and enhance the ferromagnetism. At different temperatures, sample with 0.3% platinum presents irrespective saturation magnetization via experienced temperatures. At 5 Kelvin, the saturation is not reached and it is also remarked a shift of the hysteresis loop which called interfacial exchange bias. Remember that the exchange bias appears when a ferromagnetic-antiferromagnetic interface is cooled in the presence of a magnetic field through the Néel temperature of the antiferromagnet. Now we will present the structural and magnetic study of nickel platinum deposited on Syria reduced via gamma rays. The X-ray-D patterns of irradiated samples showed the same cubic crystal structure of support presented for the reduced under hydrogen flow. Any supplement peak is presented that the irradiated sample present always a thin structure. VSM hysteresis loops at 5 Kelvin for irradiated samples present a ferromagnetic behavior and also an interfacial exchange bias is remarked. Whereas at 300 Celsius degrees the samples show paramagnetic behavior, this is due to the thermal agitation factor small grains which are the orienting couples don't contribute to magnetic. At conclusion, formation of nickel metallic phase for hydrogen-reduced samples. Some observations noted a good metallic dispersion. Magnetic study showed a ferromagnetic behavior for all samples at all temperatures except irradiated samples at 300 Kelvin, which present a paramagnetic behavior. An exchange bias is also presented at 5 Kelvin. The highest saturation magnetization values are assigned to 0.3 and 0.5% platinum amounts. Thank you for your attention.